Hi everyone, this is Miss Cubbin and we're doing question number 2 of the worksheet. So what it has is Li plus O2 goes to Li2O. Sorry. So if you missed the message, there was actually a typo. I think it had fluorine in the products. And obviously we can't create fluorine out of nothing, so it was meant to be lithium. So sorry if that caused any confusion. So we can start with balancing this question. So we've got the first step is to separate the products right here from the reactants over here. So step 1, step 2 is going to be to count each atom. So we're going to write lithium and oxygen on both sides. And how many lithiums do we have right now? There's no subscripts. We just have 1. For oxygen, there is a subscript. It says 2, so that would be 2. There. So over here we have these 2 combining to form lithium oxide. So we've got 2 lithium because of that subscript. And oxygen, again, doesn't have anything. So just 1. So here we can see we have 1 lithium on the reactant side and 2 on the products, so we need to do something to fix that. So, easiest thing, let's put a 2 in front of the lithium. Okay, so then this 2 times 1 becomes 2. So we're like, yes, lithium's good. Okay, but the oxygen over here we have 2, here we have 1. So we don't want to put anything here, because we have more over here. We want to put something over here. So over here, something times 1 to give us 2, well, that would be 2. Easy. So now we have 2, 2. Okay, we're done. Wait, hold on a minute. Not quite done. So that 2 times 2 here for the lithium also applies, or sorry, the 2 times oxygen also applies to this 2 here for the lithium. So we no longer have 2 here, we actually have 4. So that's not a check mark because over here we have 2 still. So can we go back and change this? Yes, we can. So we can erase that. This is why it's really good to do our chemistry in pencil. We can erase that because we have 4 over here now. So 1 times 4 gives us 4, so we can just change our coefficient to 4. This becomes 4, and we have 4 lithiums over here. Again, we have 4 over here. We can change that back into a check mark. Woo! Lithiums are done, and let's triple check the oxygen's 2 on this side, 2 times 1, 2 on this side, check, and we have a balanced equation. So that would be the answer for this one. The second part of the question is asking what type of reaction it is. So this, we have 2 reactants. I can't see that. So we have 2 reactants, and then we end up with 1 product. So that would be a synthesis reaction. So synthesis reaction, because you start out with 2 things and you end up with 1. So that would be a synthesis. Okay, so that's question 2. Okay, so this is question number 6. Sorry, I'll just zoom out a little bit. Zoomed in automatically, but excellent. So question number 6. So you can see that now. So we have our coefficients blank here, here, and so we start with our first step for any balancing. Draw a line between the reactants and the products. So I've got, now I'm going to count them. So I've got carbon, hydrogen, and oxygen, and I'm going to remember to write this the same on this side as well, even though I want to write carbon, oxygen. Still really important to keep it in order, otherwise you might get mixed up with what is what. So, counting our atoms. So carbon, we have 1. Hydrogen, subscript says 4. There's no coefficient, so I'm not multiplying it by anything. Just 4 for now. Oxygen, 2. Okay, then we go over to the products, and we're going to count again. So carbon, 1. Hydrogen, 2. Now oxygen is a little tricky here. We've got it in 2 places, so we have to make sure to count it in 2 places. So we've got 2 here and we've got 1 over there. So it ends up being 2 plus 1, which gives us 3, okay? So this seems a little tricky. Where do we start? So I'm going to start with my hydrogens because I have carbons look fine right now. So I'm going to do a little check. Carbon's 1 on both sides. That's good. So hydrogen 4 on this side, only 2 over here. So I'm going to multiply this 2 to give me 4 by 2. So that's my coefficient here. Okay, so hydrogens are now checked. Can't forget, I multiplied that by this whole molecule by 2, right? So over here where it says 1, that's wrong now. So instead, we have 2 plus 2 equals 4, which actually kind of helps us out because now we have 4 over here, we have 2 over here, and we can do the simple multiply by 2 to give us 4. So 2 as our subscript multiplied by 2 gives us 4. We can check that it's just single oxygen, nothing else is being changed. And let's double check. Carbon 1, 1, good. Hydrogen 4, 2 times 2 is 4, yes, that's right. Oxygen 4, 2 times 2 is 4, yes, that's right over here. Oxygen 4, 2, yes. 2 times 1 is 2, plus add them together is 4. Yep, that's right. Okay, so we're definitely sure this is balanced. So that is our first part of the question. Good. Second part is what type of reaction this is. So this might be a little bit tricky, but remember, this is the type of reaction that we start with a carbohydrate, we burn it, which means we add oxygen, so it's burning, and we always end up with carbon dioxide and water. So that would make this, no question, a combustion reaction. So that is question number 6 done. Okay, so this is question number 8. We've got chromium and oxygen here, so I've already drawn the line here to separate out my reactants and products, and now I'm just gonna write them out. So chromium and oxygen, I like to write them all out first and then count them after. You can count them as you go if you want though. So chromium, I've got 1, oxygen, I've got 3. Here I've got 2 chromium, 3 plus 2 oxygen. So I actually have 5 because since there's this plus sign here, you add the 2 subscripts together. Okay, so this looks like it's going to be challenging, but that's okay. So let's see. I've got 2 on this side of chromium. Let's try 2 here. So that gives us 2 times chromium is 2. 2 times 3, 6 oxygens. Okay, so my chromiums are good. I could do a little check there. Oxygens are not good. So let's play around with this a little bit. I don't want to change my chromiums because they're good right now. Might have to later, but let's try doing 2 oxygen first. So 2 oxygen. So I've got 3 plus now, because that stayed the same. 2 times 2 is 4 equals 7. Shoot. Okay. So it looks like I'm going to have to change the chromium because 7 is more than 6, and that was the lowest I could go, because we don't do halves, remember. So I'm going to go back here, and I'm going to go, you could go up by 1 if you wanted, but I'm going to be smart about this. I'm going to see that this is a 2 here, so if I go up by 1 it would be 3 times chromium. I can't have 3 times chromium, so I'm going to go up by try 4 instead. So 4 times chromium. So again, this is why erasers are good. I could just cross that out because I have a little bit more space. So that's 4. I'm going to erase this because I ran out of room for myself. So 4 times 3 gives us 12. So that's what that 4 does over there. So I now have 4 chromiums. I know I want to get rid of that check mark. It's no longer balanced on the chromiums. So I want 4 chromium over here. So to do that, I multiply this by 2. So that would be 4 chromiums. Then again, remember your oxygen's changing now, so 2 times 3. So these are all wrong. We've got 2 times 3 is 6, plus what we have right now is 2 times 2, 4, equals, sorry, that equals 10. I was getting ahead of myself there. 10, don't really want 10, I want 12, right? Because that's what I have over here. So I'm going to say no, not 10 equals 12. 6 plus what? So I go back here, this is by itself. I know 6 plus 6 equals 12 because I know my math skills, and I know I can do a 3 here times 2 equals 6. Okay, so that might have seemed a little fast. If you need to watch it again, you can, but let's go over this again just to make sure. So we have 4 times chromium here, so 4, yep, that's good. And over here we have 2 times 2 equals 4. Okay, my chromates are good. Oxygen took a little bit more work as we expected, so oxygen we've got 4 times 3 is 12. And over here we've got 2 times 3 is our first 6, plus, oops, dropped my pen. 3 times 2 is our second 6 equals 12. Awesome, so that means our equation is balanced. So good job, everyone. So now that we've balanced it, we will have to figure out what type of reaction it is. So you start with one reactant and you end up with 2 products. So that would make this a decomposition. So this is question number 10, and we are going to start like we always do by separating the reactants and the products. And now again we're going to count them. So I'm going to write them both on both sides first, like I always do. Again, making sure you write them in the same order, even if the products may turn up in a different order, you want to write them in the same order. So calcium, no subscripts, I've got 1. Hydrogen, 2. Oxygen, 1. Calcium, no subscripts, just 1. Hydrogen, so now we've got this in 2 places, so it's a little bit trickier, but we can say hydrogen, the brackets means that is 2 to everything inside the brackets, so we have 2 hydrogens, and then we add plus 2 hydrogens. 4, and then oxygen, again, like I said, the 2 applies to everything inside the brackets, so it's 1 times 2, so that's 2. Alrighty, so I'm going to leave the calcium alone for now, because it starts out as 1. Hydrogen I want 4 of, at least, so let's try that. So 2 times 2 is 4, so put a 2 here, so that's 4. And then don't forget 2 goes to the oxygen as well. That's 2. And wow, that was pretty simple actually. Looks like that is, I started with the lucky one. So we've got 1 calcium, good. 4 hydrogen, yep. 4 hydrogen, 2 plus 2, yep. 2 oxygen, yep. 2 oxygen, yep. Okay, that's balanced already, nicely done. So now we're looking at what type of reaction this is. So that might look a little challenging. So to figure this out, I'm going to rewrite H2O here as HOH. So if we write it like this, we can see this calcium comes in here and bumps out this hydrogen to become CaOH, and you leave hydrogen by itself. So maybe that helps you see how this separates out. So actually I'm going to write it out below here as that. So we have calcium. Sorry, this red marker doesn't work very well and it's not in your view, so I'm going to change back to blue. So we have calcium plus HOH goes to calcium OH 2 plus H2. If I was to balance it, I'd just put that there. So you can see we've got this coming in here. If you remember way back when we were in class, and I said when you see you can draw a single arrow showing something replacing something, that means, I'll draw it up here, sorry, just one arrow showing what's being replaced. That means it is a single replacement. So I'll write that up here. So we've got a single replacement reaction. Oops, got ahead of myself. So this is a single replacement reaction. So calcium bumps out the hydrogen, and we get calcium oxide and hydrogen gas. Okay, so that's what's happening in this reaction. Okay, so this is question 11, and let's get started. So first step, as always, separate out the reactants and the products. Now we're going to write out the atoms that we have, and then we'll count them. I was about to write O here, but remember we want to keep it in the same order as over here. So that's not an O, that's an H. Otherwise you might get confused with how many of each thing you have. Not thing, atom. Okay, so carbons, I'm going to count this subscript, is 6. Hydrogen, okay, we've got 12. Oxygen, we've got it in 2 places. So again, that plus sign there means we add it. 6 plus 2 is 8. So that is our reactants. Products, we've got 1 carbon. Hydrogen, we've got 2. Oxygen again is in 2 places. We've got 2 plus 1 equals 3. So you can see everything here is out of balance. We need to find our coefficients so that we can balance it. Okay, so I'm going to start at the top here. So carbon, 6 over here, sorry, and 1 over here. So super simple, 6 here. So 6 there, so that turns into a 6. And now our oxygens change as well. 6 times 2 is 12, so I've got 12 plus 1 stayed the same. You can cross that out, make sure you don't get confused. And that means we now have 13 oxygens. Okay, so our carbons are good for now. So I'm just going to keep going down the list here. So hydrogen is next. So we've got 12 over here and 2 over there. Simple solution is 2 times something to give us 12. So 12 divided by 2 is 6. So I'm going to put another 6 here. So I've got 6 times 2, so that's going to be 12 now. So my hydrogens, okay, they're good here. Whew, that's good. My oxygens have changed again though, because 6 times 1 is 6. So we've got that crossed out, but we've still got this 12. 6 times 2 is 12. Oh, I've ran out of room. I'm going to move it over here. So 12 plus 6 times 1 is 6 equals 18. Wow, that's a lot of oxygens. Okay, so that's our number for oxygen over there. And currently we have 8 over here. So we've got, I wonder if we can just, we don't really want to mess with our carbon and hydrogens because they're looking pretty good. So I wonder if we can put a number here, right there, that will help us out and get 18 oxygens over here. So right now we've got 6 plus something, and we want it to equal 18. So I can do the opposite. So 18 minus 6 is 12. So I actually want 12. So that's how many oxygens I want here. And currently I have 2, so I can do the same thing I did earlier to 12 divided by 2. Just nudge this a little bit so you can see that. So 12 divided by 2. And that would be 6, so that would be the number I put up there. And that's as easy as it is. So let's just double check everything, okay? It's always good to make sure you check your work. So I've got 6 carbons here, yes. I've got 6 carbons here, great. And carbons are still good, I didn't mess with those. Hydrogen, 12, okay, 12, yep. And 6 times 2, 12, okay, we're good there. Oxygen, this is the tricky part, so let's double check. So we've got 6 here, so that's the 6, and then let's make sure we did this right. 6 times 2 is 12, it was 18, awesome. Okay, then over here we've got 12, so 6 times 2 is 12 plus 6 times 1 is 6. 6 equals 18. Awesome, so that means our oxygens are good as well, so that is our balanced chemical reaction. So now you might be wondering, well, what type of reaction is this? It's a great question. We can tell based on both what our products are, and our reactants. So we have a carbohydrate here. This is our carbohydrate, and it is burning, and I know it's burning because our other reactant is oxygen. So our carbohydrate is burning. Maybe that's given you a hint already, and you're already thinking you know what it is. And our products in this type of reaction are always carbon dioxide and water. So that would make it a combustion reaction. So that is our combustion reaction. Remember, it's what happens when you turn on a barbecue. Okay, so that is our combustion. This is question number 16. So for balancing this question, so again, start like we always do. I'm going to draw a line down the middle, right where the arrow is between the reactants and the products. And now I'm just going to write out my elements and then count them. So I've got ASCl, H, and S. Okay, and then write the exact same thing on the other side in the same order. And now we get to count them. So start with AS, got 1, no subscript. Chlorine, subscript is 3. Hydrogen, subscript is 2. Sulfur, 1. Then here we've got 2. Chlorine, 1. Hydrogen, 1. Sulfur, 3. Okay, so you can see clearly it is not balanced because actually none of these numbers are all the same. So we need to put some coefficients in. So I'm going to start with arsenic. There's a 2 here. Let's try a 2 over here. So I've now got 2 here, and chlorine is now 6. So we've done that. Okay, so arsenic's good. So I'm going to go over to chlorine. So 6 over here now, so let's make this 6. So 6 in front here, so that's 6. And then don't forget that also applies to the hydrogen, that's also 6. Okay, so chlorine's good. Okay, but now hydrogen's not, so I've got 2 here, and over here I've got 6. So I'll multiply 2 by 3 to get 6. So I'll put my coefficient of 3 up there. That becomes 6. Then also sulfur becomes 3. And if you look at that, 6, 6, 3, 3, oh, magic. It is balanced. Okay, so, oops, sorry. Just trying to get that glow spot off. Okay, anyways, hopefully you can still see that. So that is now our balanced reaction. We can double check if we want, but it is balanced. So those are our coefficients that we needed here. So now the next question is, what type of reaction is this? And I can tell what type of reaction this is by drawing some arrows. So I have arsenic here with chlorine, and it recombines with sulfur, so I can draw an arrow like that, and then chlorine goes with hydrogen over here, so I can draw an arrow, an arrow like that. And if you remember from when we were doing these questions in class, whenever you have 2 arrows that you can draw like that with recombinations, that makes it a double replacement reaction. So if you remember some of the analogies for this one, it's kind of like if you have 2 partners dancing and both partners switch partners, right? So arsenic recombines with sulfur, this arrow here, that's one trade, and then chlorine and hydrogen are left alone, but then they combine together. So they recombine as a double replacement. So hopefully that makes sense. So this is question number 18, and this was one that a lot of people had problems with and wanted help with, so I will go over it now. So again, start with drawing your line down the center here, and write out your elements. So we've got sodium, hydrogen, boron, fluorine. And even though we start with B here, we're still going to write sodium first because it keeps us on track with our numbers. So we've written them out, now we're going to count them. So sodium is 1, hydrogen 1, boron 1, fluorine 3. Sodium 1, hydrogen 6, boron 2, fluorine 1. Okay, so this is our second step, and now we're going to balance. So sodium looks good for now. Hydrogen, definitely not. So let's change hydrogen. So we have 6 here, let's put a 6 over here. So I now have, oh, my sodium changed as well. We can get rid of that, that's not good. And hydrogen 6. Okay, so hydrogen is now good. Sodium is no longer though, but so I'm going to have to change that. So 6 over here, so let's put a 6 over here. So that's 6. That's 6, but then I also changed fluorine to 6. Okay, so sodium is good now. Now let's go to the boron. So we've got 2 here. So 1 here, let's change that to a 2 then. So that's 2. And now we remember we changed the fluorine too, so 2 times 3 is 6. And there we go. That is balanced. So you can double check if you want, but that is the balanced reaction. And now we are going to talk about what type of reaction it is. So again, just like the last one, I can draw 2 arrows with what recombines. So sodium now goes with boron, and boron goes with hydrogen. So that is our reaction there that we have. Okay, so that makes it a double replacement because I can draw 2 arrows showing that. Okay, so that is our double replacement reaction, and that is it's balanced. Okay, this is question number 19. Again, start out like we always do. We're going to draw our line here. Ooh, that was a little crooked. Anyways, draw our line there and count out our atoms. So this one here, I'm going to start with K, O, H, and now if you remember, PO4 phosphate is a cookie, so I can see that it is the same on both sides and it hasn't changed. So what I'm going to do is I'm going to write it together because I find that easier. If you find it easier to write P by itself and count these O's with those O's, you can do so. I find it easier to do it together, so that's the way I'm going to do it. Okay, so we've got that on that side, and then over here, again, we should have the same. If we don't have the same, something's wrong. But we do, so that's good. So now we're going to count our atoms. So again, for O here, I'm just counting this O because those 4 oxygens are included in my PO4 there. And that's not a 0, that's a 1, sorry. And that is, oh, and I've done a mistake again, so I counted that one, but I forgot to count that one, so remember plus. So I'm going to add 3 equals 4. Okay, so maybe you caught that before I did, but then over here we count these 3, go down to here, this is just 1 for the whole cookie. Oxygen, we've just got 1, and hydrogen, we've got 2. Okay, so those are my elements and polyatomic atoms. So we'll start with the top here. So we've got 3 potassium over here and 1 over here, so let's put a 3 here to make that 3. So that is good. And then remember we've now multiplied the O and the H. So I've got 3 oxygen and I've got 3 plus 3 equals 6. Okay, so let's go over here, oxygen. Okay, so I have 3 on the left for the reactants, so I need 3 over in the products, so I'm going to put a 3 up here. So that becomes 3, and those are matched. And now don't forget 3 times 2 for the hydrogen, so that becomes 6. Oh, nice, that's what we wanted. And PO4 stays as 1. We don't have to change that, so that would be our balanced reaction. If you want, you can double check again, like I did in the first few videos, on how many those, but I'm going to move on to the type of reaction. So if we wanted, we could write H2O like HOH, which might help with the next step. Okay, so that's another way of writing H2O. So we can see here, potassium combines with PO4. Oh, you cannot see that at all. The red is not working. PO4. And this OH here, if you write it like this, it might be easier to see. That actually combines with that H there. So if you do that, you can see this is a double replacement. So it's I'm going to just write DR for short because there's actually something else going on here. So that's a double replacement, right? But then we could be like, oh wait, but we made water and a salt. Is that a base and an acid? Oh my gosh, it is. So if you remember, we have it's a very specific type of double replacement reaction because you have a base and you have an acid that react together and they neutralize each other, and you end up with a salt. So this is our salt and this is water. So this is our base and this is our acid, and they neutralize each other. So you can call this either a neutralization reaction, or you can call it an acid base. I'm running out of room here a little bit. I'll just write it really small. So that is our type of reaction. So it's a little bit more specific than double replacement. It's an acid base or neutralization. This is question 20, our last one. So we are going to start like we always do and draw a line down here. And now we're going to count. So we've got aluminum, we've got oxygen, hydrogen, and chlorine. Okay, do the same on the other side, again in the same order. We don't want to mix up the order because it might end up confusing us later. So counting our atoms, we have 1 aluminum. Oxygen, we have 3 because 3 is outside the bracket, so it applies to everything inside of it, so that's 3. Hydrogen, we have 3, but then we have 1 over here, so we can't forget that one, so we actually have 4. So 3 plus 1, 4, and chlorine, we have 1. So here we have 1 aluminum, oxygen, we have 1. Hydrogen, 2, and chlorine, we have 3. So we'll start at the top. So aluminum's good for now. That might change, but for now it's check. And oxygen, we need more of on the product side. We have 3 on the reactants. We want to have 3 over here, so I'm going to put a 3 in front of the water. And that also, remember, changes the hydrogen. So that's going to give us 6 because 3 times 2. So I'm just going to go over that. That's kind of a little thin. Okay, so our oxygens are good. Hydrogens, mess those up over here. So let's see if you can fix that. So I've got 3 here. So now here we're adding them. So what we want it to be is we want it to equal 6. And the question is, do we change this hydrogen or do we change this hydrogen? And what we want to look at here is what they're combined with. So this hydrogen is combined with aluminum. Right now aluminum is good. We don't really want to change it. So first, instead of putting, what would I put? Oh, well, I can't even do that because it would be 3 times something plus 1. So it would be 5. You can't multiply 3 by anything to get 5. So then I would have to do this side again. Anyways, it would get very complicated. So I'm looking at it, I'm seeing, well, this hydrogen over here is attached to chlorine, and then chlorine needs to change anyways. So let's put a coefficient here. So I'm going to leave this one as the same, so 3, and then 3 plus what equals 6? 3 plus 3. So I want this question mark to be 3. And, well, that's easy. I just put a 3 here. So 3 times 1 is 3, so that's that 3 there. 6, and then we have 6 over here. That's good. And then 3 actually also multiplies by the chlorine, which we knew it would. And wow, that gives us 3 there, which is what we wanted. And we have a balanced chemical reaction. That's awesome. So, thumbs up. Okay, so now we need to look at what type of reaction this is. So again, if you want, you can write HOH for water. That helps you with this part. So what I have here is I have aluminum combining with chlorine, right? And I have an OH combining with an H. And that gives us aluminum chloride and water. So this, you might be like, ah, nice, double replacement. But again, just like the last question, we have to look at what's involved. So I see I'm making water. So that gives me a pause here. And so I look back and I'm like, oh, well, this is a base. Because there's this OH here. And this H, well, that's just hydrochloric acid. We know that one's an easy one. That one's a really big acid. Okay, so I have a base and I have an acid. And I'm making a salt. And I'm making water. So that gives us a neutralization reaction, which can also be called what? It can also be called an acid-base reaction. Okay, so those are the last questions. Hopefully that was helpful. If you still have questions, you can send me a message and ask me about them, but that is all of our reactions.